Hi guys, it's Jason here. Welcome to my series of videos about linked lists. The reason why I'm doing this series of videos is because I think linked lists is one of the hardest, if not the hardest, concept of the entire course. And a lot of students that I know struggle with it. I certainly struggled with it. And hopefully throughout these set of videos, you would be able to reinforce your own understanding of linked lists, or if you're not familiar with them yet, maybe learn a few basic concepts. And also by explaining them to you, I could reinforce in my own head my own understanding of linked lists. So I help you, and it helps me. It's a win-win situation. So that's kind of the motivation behind these series of videos. So that's just a brief introduction. Now we'll get into the meat of it. So when we have linked lists, what is a linked list? A linked list is basically a series of items, and these items are linked to each other in some way. So what we have is a set of nodes, and each of these nodes will contain two things. Firstly, they'll contain values. So for instance, the first node will contain a 7, the second one a 4, the third one will contain an 8, and let's just set the last one to say 6. So that's the first thing. Every node must contain a value. The second thing that they must contain is a pointer to the next node. So in other words, the first node, which contains a 7, must also contain a pointer to the next node, which contains a 4. The second node must contain a pointer to the third node, and finally, the third node must contain a pointer to the fourth node. And this is why it's called a linked list, because each of these elements link to each other. And in order to read the list, you must follow the arrows. So that's the basic diagram of a linked list. But we're not finished yet. There's two key questions that are left to be pondered. First of all, how do we know where it starts? And secondly, where does it end? So first I'll start with where it ends, because that's a bit easier. To denote the end of a linked list, we set the last pointer, which is the last node, which contains a 6, to point to null. And once we reach null, we know that we have reached the end of the list. So that's how we know where the list ends. Now, figuring out where the list starts is a little bit more difficult. First, we must create something else called a list. This list will contain a pointer, which we will call a head, which points to the first node. So, we have two things here. We have a list, which points to the first node, and then a series of nodes which point towards the next nodes, which finally ends at null. So I'll write what we have so far. Each of these circles is what we call nodes. So we have a node here, node, 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 node. This X here, the last thing, is a null pointer, so we'll call it null, and that indicates the end of the list. And this thing, this red thing in here, is what we call a list, with a small l. I'll explain the significance of a small l in a second. Okay, so what about the arrows now? Let's name some of the arrows. Remember how I said every node must contain two things, a value and a pointer to the next one? So these arrows we are literally going to call next. So next here, next, and next literally points to the next node in the sequence. But the last node, the value of next, will be set to null. Okay, so we're almost there. And finally, to fill in this last arrow, we call it differently to the others because it's marks the first element of the list. So that's why we call it the head. So Now we have our representation of a list. Well, almost. Here we have a representation of a concrete list. But ideally, we want an abstract representation of a list. And why? Because we don't want the user of the list to see what's inside the list. We want them to be able to use the list without knowing what's inside of it. So what we do here is we use a little bit of C magic and we define another pointer. And this pointer is going to point to the list, and rather confusingly, we're going to call it a list. But this list has a capital L and is very different to the list with a small l, because the list with a capital L means it's an abstract data type. So this is our basic representation of a list, at least in a diagram. So what we're going to do next is try to convert this diagram into C code. So let me just open up list.c. Alright, so from our diagram, the first thing we should probably define is what a node is. So we're going to go type div struct node, and we're going to call it a node. And remember I said a node has two things. First, it must store a value, and secondly, it must store a pointer to the next node, and we'll call this node pointer next. Now, if you're observant, you'll notice something right away. We have used the type node pointer, but we don't know what a node pointer is. So what do we have to do? We have to type def it first. Now this is where the magic comes. So we type def a node pointer to be a pointer to a struct node. Normally C doesn't let you do this. However, don't forget the asterisk. The asterisk is very important. When we do it in this way, we know that a node pointer is a pointer to a struct. And then we define the struct afterwards, and this is the only instance that C forgives us. Note that we can't put this at the bottom, because if we do so, C is going to freak out and say, what the hell is a node pointer? So that's why we have to put it at the top. And using this magic trick, it's quite convenient. So that's how we store a node. The second thing we need to store is the list itself. So to store the list, we're going to create another struct. And in this struct, it's just going to contain one field, and that's just simply the head. So in here, we're just going to have a pointer to the first node, and we're going to call that pointer head. Alright, so we're almost done. So diagrammatically, what we have done here, we've done the black stuff, we've done the red thing. The only thing missing is the blue thing, the capital L list, which is our abstract data type. And because it's an abstract data type, we're going to put this in list.h. So transfer to list.h, and we have type def struct list star capital list. So this means that list with a capital L is a pointer to a struct list. And what is a struct list? It's basically this thing. So that's basically how we represent a list diagrammatically. And in the next video, I'll be talking about some useful functions that we might want to implement with a list and make this type more than just a type and actually start using it for things. So until then, see you later.